Hi, grade 10 students. Our aim today is to explain system of two equations with two unknowns using addition method. At the same time, it's called the elimination method. Let us recall back. A linear equation is an equation of the form y equal mx plus b, where m is the slope and b is the y-intercept. So our aim in that lesson is to find the intersection point if it exists between the two lines. Suppose I have, this is the first line, ax plus by equal to c linear equation, and I have another line, a prime x plus b prime y equal to c prime. My aim, if I want to graph these two lines in x and y axis, I'm going to get two lines. This is line L1, for example, and this is line L2. My aim is to find, by solving that system, I need to find the point of intersection if it exists. So this is line L1 and this is line L2. So let us start before we take examples to talk about relative position of two lines. Two lines can be intersecting like this one, and the intersection is a point A. In that case, we call the system a consistent system with exactly one solution. It's called independent. In that case, when we're going to solve the system, we're going to see later, if we solve for x or for y, we're going to get ax equal to b, where a is not 0. The most important coefficient of x is not 0. If coefficient of x is not 0 when solving, it means we have one solution. Another relative position when the two lines are overlapping. So here I mean I have two lines. This is line L1, and at the same time it's line L2. So here we have infinitely many solutions because the intersection is any point on that line. This is called consistent system with infinite number of solutions because the two lines are the same and the intersection is a whole line. So when we're going to solve the system, we're going to get 0x equal to 0. What does this mean? No matter what x you're going to replace here, and for any value of x, 0 times any number is 0. So I have infinitely many solutions. So this is called consistent dependent. The third one, when two lines are parallel. If two lines are parallel, so we don't have a common point. So if you want to solve the system, it's impossible to solve it. We're going to get 0x equal, for example, to a number not 0. 0x equal to 5. Is 0 can be 5? Actually, it's not possible. It's impossible. In that case, we call the two lines, we call the system as inconsistent. We're going to see the examples. First of all, as we said, we're going to use the addition method. The addition method is we're going to cancel either one x or the x's or the y. It depends on which one we're going to pick or which one is better for calculation. So it is, we're going to add together these two equations. In a case, we're going to eliminate either x or y. Let us take the first example. Suppose 2x plus 3y is 8 and 3x minus 6y equal minus 9. I can eliminate y or I can eliminate x. Suppose I want to eliminate x. I have here 2 and here 3. So my aim is to get the same number up and the same number down. When I add it to it, I will get 0. And to get a 0, for example, I will find first of all the least common multiple between 2 and 3, which is 6. So my aim is to get up 6x and down 6x. But one must be negative and one must be positive. So that's why when we're going to add, we're going to eliminate x, so 0, plus something of y equal to a number. So in that case, we can find y. So that's why a note, if both are positive, to get one negative positive, I multiply one by minus and the other by plus. If they are opposite sign, I multiply both by positive. We're going to see in that example. Suppose here, this the example that we talked about. So this common multiple is 6. So to get 6, so I must multiply by 3. Here to get 6, I must multiply by 2. But I picked the first one to be minus. I can put here minus, but not both minus because I want opposite sign. So if I multiply minus 6x minus 9y equal minus 24, 6x minus 12y equal minus 18. You can realize that I have, if I want to do the addition method, minus 6x plus 6x, here I have addition method, cancel out, I'm left with minus 9y plus minus 12y is minus 21y equal minus 42 if I add these two. So in that case, y is 2. To find x of the point, I replace y2 either here or here. You have the choice, you're going to get the same number. So if I replace it in the first, I'm going to get 2x plus 3 times 2, which is 6, equal to 8. So x is 1. So in that case, I can say that these 2 points intersect in the 2 lines intersect in a point A, whose coordinates are 1, 2. This is called consistent independent. If I take another example, the same story. So here I want to cancel y. Let us cancel y to pick something else. These two are opposite sign, and the least common multiple between 5 and 10 is 10. So I must get here a 10 and here a 10. Already here I have a 10, so I multiply the first equation by 2. I don't put minus because the two equations are of opposite sign, minus 5y and 10y. So if I multiply the first one by 2, I'm going to get minus 6x minus 10y equal to minus 2. And the second one as it is, if I add here, as you can see, I'm going to cancel 10 minus 10y and 10y. So I'm left with minus 2x is minus 4, so x is 2. If I replace x is 2 by here or here, the equation you want, you may get y is minus 1. So the point of intersection of these two lines is a point A whose coordinates are 2 minus 1. So it's called consistent dependent. Remains two examples. Suppose I have this example, and suppose I want to cancel x. I have 3 minus 15. You know that the least common multiple is 15, so I multiply up by 5. So I'm going to get 5 and positive y because they are already of opposite signs. So if I multiply here, I'm going to get 15x minus 25y equal to 10, and the second one the same. If I add here, I do the addition. This and this cancel out, that and that cancel out, that and that cancel out. So I'm going to get 0x or 0y equal to 0. As we said before, when 0x equal to 0, this is called consistent dependent. The two lines are the same. Line L1 is the same as line L2. We say that the two lines are overlapping, and I have infinitely many solution. All the lines are, every point on that line is a solution. And to finish, let us take the third example. So here you have 6, here you have minus 2, already opposite sign. So I multiply up by 3 because the least common multiple is 6. So you're going to get minus 6x plus 9y equal minus 21. Now if you add here, if you do the addition method, this and this cancel out, that and that cancel out, remains 0x or 0y equal minus 20. 0 equal to a number which is not 0 is impossible. So we say it's inconsistent system. The two lines are parallel, impossible, no solution. So the lines are parallel, so no points of intersection, so no solutions. Okay, I hope that you got this video. I want you to watch it more than one time, and hope that you will understand the objective of the addition method. Thank you.